Hi, everybody. It's Professor Mitchell. We're continuing with Chapter 6, and today we're looking at Section 6.4, factoring trinomials of the form ax squared plus bx plus c by grouping. So this is exactly the same kind of trinomial that we talked about factoring in the last section. It's just this time we're going to be using a different method. And for those of you who have taken algebra before, in high school, for example, it's likely that this is the method you might have learned. A lot of people do prefer this method because it's a little more systematic, a little bit less guessy, as I like to say. All right, so that's the only objective in this section. Use the grouping method to factor trinomials of the form ax squared plus bx plus c. And we're still working on the same student learning outcome that we've been working on throughout this chapter. All right, so the grouping method for factoring trinomials is also sometimes called the AC method. I'll explain that to you here pretty soon. All right, so here are the examples, and as usual, I'm going to pull up my tablet and we'll go over these one by one. And again, I encourage you, once you think you're starting to get the hang of it, pause the video at the beginning of the next example, try it, and then come back and compare notes. All right, so let me switch over to my tablet. So this first example actually could have come out of section 6.1 because this is already set up to use grouping. Notice that it has 4 terms. So gives us a good excuse to review the grouping method. First of all, what do we always do at the beginning? We look for a greatest common factor, which in this case, I don't think is going to be any help. Let's see. Well, no, it's not going to be any help. 4x squared and 9x have an x in common, but they don't have any number in common. And then the 72 doesn't have an x. So there is no factor that all 4 of these terms have in common. All right, so if you remember the grouping method, the way that worked is we group the terms together. And we look to see what can we pull out of the first 2 terms. I can pull out an x, which would leave me with 4x minus 9. And then remember, in order for grouping to work, I have to get the same binomial over here. So what you can do is say, okay, I know I need this to be a 4x minus 9. What can I pull out of negative 32x plus 72? So that one of the factors is 4x minus 9, it would have to be a negative 8, right? Negative 8 times 4x is negative 32x. Negative 8 times negative 9 is plus 72. So my common factor is 4x minus 9, which would leave me with my other factor, x minus 8. Don't forget, it's never a bad idea to check these. I think I'll save the check for the next example because often I do that. I'll be sure and do a check the first time that I do a new kind of problem or, use a new method. So that's what I'm going to do. Sorry, I'm having a little trouble finding there we go, finding that button. Okay, so this does not look like grouping because it has 3 terms. So if you notice the difference between this and the example that we just went over, that minus 9x minus 32x, this was totally rigged to make the grouping easier, all right? Now, normally, if we were doing the chapter 5 problem, multiply 4x minus 9 times x minus 8, 4x squared minus 9x minus 32x plus 72 is what we would get in the second to last step. and then I would combine the like terms and ultimately come up with 4x squared minus 41x plus 72. So that step has been taken in this problem. So I can't use grouping, at least not the way it's written now. Just to stay in the habit, I'm going to look for a greatest common factor, and I think it's pretty clear this time that the greatest common factor is 1. All right, so here's how the AC method works. I am going to rewrite this as a polynomial with 4 terms. In other words, I'm going to kind of uncombine that minus x, but I have to do it in a very specific way so that I can factor by grouping. So long time ago, I have no idea when, some clever person noticed that you can do this trick. And for some reason, I see a lot of people make a diagram like this. So hopefully this looks familiar if you've taken algebra before. So what I'm doing at this step is I'm thinking up 2 mystery numbers. And what these mystery numbers have to do is they have to add up to -1, because that's the coefficient on the middle term. And they have to multiply not to -9, but to the product of 8 times -9, which is -72. So that's why it's called the AC method, because when we talk about a general trinomial of this form, we call these numbers A, B, and C. All right, so we need 2 numbers that add up to -1 and multiply to -72. And after you think about it for a minute or so, you realize that those numbers are 8 and -9. Or you could do -9 and 8. It'll work either way. All right, so what that -9 and 8 tell me, in whatever order you write them, is that's how I want to split up the middle term. So instead of writing -x, I'm going to write plus 8x minus 9x. Keep the other terms just the way they are, 8x squared plus 8x minus 9x minus 9. And now I can factor that thing by grouping. Okay, so that's going to work exactly the same way as in the last problem. I look at the first 2 terms, and what they have in common is 8x. I pull out 8x, and I'm left with x plus 1. And then in order to get an x plus 1 here, I would have to pull out what? -9, right? So then my common factor is x plus 1. My other factor is 8x minus 9. All right, so let's check that one because we're doing this a new way. So remember, the check is just take your thing that you think the answer is and FOIL it back together. FOIL. X times 8x is 8x squared. X times minus 9 is minus 9x. 1 times 8x is 8x. 1 times minus 9 is minus 9. Lo and behold, I combine my like terms and I come up with 8x squared minus x minus 9. Woohoo! All right, and so my final answer for this chapter 6 problem is x plus 1 times 8x minus 9. And remember, the factors can be written in either order. So if you put 8x minus 9 times x plus 1, that is just as good. Okay. All right, so hopefully that makes sense. If it doesn't make complete sense, then let's take a look at the next example. All right, so hopefully after this example, you'll be ready to try one on your own and then come back and compare notes with me. All right, 10x squared minus 23x plus 12. Once again, the GCF is 1. Sometimes it will not be 1. Okay, so now We need to come up with our mystery numbers. And what our mystery numbers need to do is they need to add up to negative 23 and multiply to, do you know what they need to multiply to? 10 times 12, which is 120. Okay, now 120 is kind of a big number. So this is where your calculator can really help you. All right. Try and come up with all the pairs of numbers that you can that multiply to 120. And remember, we can worry about the signs later. So of course, there's 1 and 120. There's 2 and 60, 3 and 40. Okay. At this point, I could ask the calculator, what's 120 divided by 4? It's 30. Ask the calculator, what's 120 divided by 5? It's 24. We got 6 and 20. Calculator would tell you that 120 divided by 7 is a decimal, so we're not going to use that one. But look at the next one. 120 divided by 8 is 15. Remember, we want our mystery numbers to add up to negative 23 and multiply to 120. So as long as I stick some negative signs in front of the 8 and the 15, then I'll be in business, okay? All right, so those mystery numbers, they tell me how to break up the minus 23x. They're telling me to break it into negative 8x and minus 15x. Keep the other terms just the way they are. And then factor by grouping. All right, so what can I pull out of 10x squared minus 8x? I can pull out 2x, which would leave me with 5x minus 4. And then in order to get a 5x minus 4 over here, I would have to pull out a negative 3. So my common factor is 5x minus 4. My other factor is 2x minus 3. And I'll skip the check on this one. Okay, remember, I encourage you to check every single one of these if you can stand to. All right, that way, you know, when it comes time to take your quiz or take your exam, you'll be able to walk away knowing that you got every single one of these right before anything even gets graded. All right, so now hopefully you can try this next one yourself and then come back and compare notes. 30a squared plus 38ab minus 20b squared. So, you know, look back at every single thing we did in the last example, the last couple examples, and then notice that we have this a squared, ab, b squared pattern, which we have talked about, I think, twice before. All right, so whenever you're ready, go ahead and pause the video, try this one, and then come back and compare notes. All right, let's compare notes. So I really hope you noticed that this one does have a GCF that's worth talking about. You can start this one off by factoring out a 2. Okay, so that'll definitely make life a lot easier, because if you forget to look for the GCF, then you're going to be looking for numbers that add up to 38 and multiply to negative 600. And if you keep at it long enough, you will eventually find them. All right, it may take you a little while. The other thing, though, about this method with GCF is that often, if you forget to look for the GCF at the beginning, you come up with something at the end that is not quite completely factored. It's more right than it is wrong, but it's not quite all the way there. All right, so let's pull out this 2, which is going to leave me 15a squared plus 19ab minus 10b squared, right? All right, so now I'm ready to think about my mystery numbers. My mystery numbers need to add up to positive 19 and multiply to negative 150. So 150 is another, kind of big number. So this time I'm going to take your word for it that you tried this problem ahead of time. If you haven't come up with the mystery numbers yet and you want to try it, why don't you pause the video again, try to come up with the mystery numbers, because this time I'm just going to tell you what they are. All right, I'll assume that I made a list like in the last example. 25 and negative 6 are the numbers that add up to 19 and multiply to negative 150. Okay, now this GCF, it's just going to come along for the ride. Leave it outside. I think I will change these parentheses to square brackets just to make things easier to read. Okay, and then the 19AB is being broken into 25AB minus 6AB. And I'm keeping the 15A squared. I'm keeping the minus 10B squared. All right, so now I look at these two terms. What can I pull out of those two terms? I can pull out 5A, right? One thing I've noticed with the A squared, AB, B squared pattern, it's a little easier to sort of navigate it with this method. You don't just sort of have to magically know how it works. It works automatically. So I'm going to pull 5A out of here, and that's going to leave me with 3A plus 5B. And then if I need a 3A plus 5B over here, I need to pull out a minus 2B, don't I? Minus 2B times 3A is minus 6AB. Minus 2B times 5B is minus 10B squared. All right, so I've still got the 2 sitting outside. My common factor inside is 3A plus 5B. My other factor is 5A minus 2B. And remember, if you want to check this one, you would start by distributing the 2 into just one of those factors, like the 3A plus 5B, right? So the first step of the check, I'm not going to do the whole thing, would be to distribute this 2. That would give you 6A plus 10B, and then FOIL that with the 5A minus 2B. I'm going to write etc. there, so you know I'm just showing you how to do part of the check. All right, last example. We have 18A to the 4th minus 3A squared minus 10. Okay, so let's see. I think GCF will not be any help this time. 3A squared and 10. They don't even have anything in common. All right, so this is a new pattern, right? A to the 4th A squared instead of A squared A. But this grouping method, I think, everything will just come out automatically the way it's supposed to. So first look for my mystery numbers. They need to add up to negative 3 and multiply to negative 180. So that's another big number. Okay, so this time I would start off, 1 and 180, 2 and 90, 3 and 60, and at some point I noticed that I'm really nowhere close to where I need to be. All right, I need these two numbers to add up to negative 3. So that means if I ignore the signs of the numbers at first, that means the numbers have to be a lot closer together than they are right now. Okay, so let's say I skip a few. 180 ends in a 0, which means that one of its factors is 10. So 10 and 18. Those are a lot closer together than the other numbers that I have. So let's just keep going from 10 and 18. I could ask the calculator what's 180 divided by 11. I would get a decimal. However, 180 divided by 12 is 15. so that will work. I need them to add up to -3 as long as I put a minus sign in front of the 15. So my mystery numbers are +12, -15. All right. Notice that also gives me the -180 that I need. All right. So I'm going to take this -3a squared and I'm going to split it into plus 12a squared minus 15a squared. I am going to keep the 18a to the 4th and the -10. And now I'm going to factor by grouping. All right, so what can I pull out of 18a to the 4th plus 12a squared? I can pull out 6a squared. And my other factor would be 3a squared plus 2. And in order to get a 3a squared plus 2 over here, I would have to pull out a -5, right? So my common factor is 3a squared plus 2. My other factor is 6a squared minus 5. And why don't we check that one? I haven't done an actual check in a little while. All right, so first, outer, inner, last. 3a squared times 6a squared is 18a to the 4th. 3a squared times -5 is -15a squared. 2 times 6a squared is 12a squared. 2 times -5 is -10. Combine the like terms and I get 18a to the 4th minus 3a squared minus 10. Woohoo! So my final answer is 3a squared plus 2 times 6a squared minus 5. All right, so as I said, I hope that you give this method and the method from the last section a fair shake. To me, the difference is, when is the first method easier and when is the second method easier? I tend to use this method when the first and the last term have a lot of different factors. All right, there's lots of different ways to break up 18, and there are a couple of different ways to break up 10. So I feel like that would be too much work to do using trial and error. If one of those numbers, or even better, both of them, was a prime number, like 3 or 5 or 7 or 2, then I personally feel like trial and error is easier. Okay, just give them both a fair shake. By the time you go to take your quiz or your midterm, I'm not going to care which way you do it, whichever one you think is easier. All right, so let's go back to the presentation real quick because I want to take another look at our bag of tricks, our list of factoring techniques. Steps for factoring a polynomial. So we started making this list last time. All right, there's Dr. Evil talking about factoring. All right, I was really into memes a few years ago when I first made this, and so maybe I'll add to it this time with a few that are hopefully a little more current. All right, step 1, always look for a GCF. Step 2, ask yourself how many terms does the polynomial have? If it has 4, that's grouping. If it has 3, you now know 2 different methods to deal with trinomials. You can use trial and error, or you can use the AC method, which we just went over. So believe it or not, we only have one more factoring section left, and that's where we're going to talk about factoring binomials, right, which is a polynomial with 2 terms. And then, of course, you can always check your answer at the end. All right. So we'll see you next time for section 6.5, which is factoring binomials.